So today what our plan is that we're going to pull together, okay, the exponentials that we covered 2 classes ago and the logs that we talked about last class. So if you'll take a look at the top of your notes, please. Okay, it says logarithms and exponentials that have the same base are inverses. That's the first blank. Okay, and inverses always cancel out. Okay, so here's what that means. If I'm looking at that first example, I have a log with a little 3, but then I also have a big 3 on an exponential. Those cross out, you just keep the A. So, whoosh, whoosh, cross them out, and you would just keep the A. But the reason that works is because the number matches. The little number and the big number have to be the same. Take a look at the second example. What is the base of my log? It's a little next to a big 5, so I would just keep the 2x plus 7. Okay, now take a look at the third one. You'll notice that you have a log little 7 and a big 7. Now, the order there is different, that the big 7 comes first and the log little 7 comes second, doesn't matter. Okay, whether you plus on a minus or minus on a plus, inverses still cross out. So I would just be left with 3C. Everybody good? Okay, so here is how we're going to use this to solve. Okay, steps to solve logarithmic equations. You are going to raise both sides of the equation to an exponent that has the same base as the original log. And then remember what I just said, as long as you have the same base, they're going to cancel out. Okay, then it says blank using common base, that's solve. Common base is the chart that I asked you to pull out. Okay, that's found in your exponential notes, but if you don't have yours, no worries. I have a copy that I'll be putting up here. Okay, and that's when x is found in the exponent. Okay, so let's get into it. Take a look at number 1. And remember, last time when we were doing logs, we were kind of ignoring, we didn't have a little number, but now that little number, you know, is the base of your log. So what is my little number on number 1? It's a little 3, then I'm going to cross it out with a big 3. And when you big 3 on a log little 3, you do have to do it on both sides, so put it on the x as well. But when you big 3 on a log little 3, they're going to cross out. So now you're just going to have what? 3 to the x over here and 81 over here. Now, for me, I typically like to keep my x on the left-hand side, so I'm going to rewrite that with the 3 to the x coming first, but we'll have that step as optional. Okay, you don't have to do that. That's really just a preference thing. Then from there, look at your chart. For those of you that were able to find it, let me pull mine out. Okay, I am looking for 81 in the base 3 chart. Okay, very good. So if you pull out your chart, 3 to the 4 is 81. Then I would say, okay, then 3 to the x is 3 to the 4. And then what do I do from there now that the 3's match? And x equals? 4. Okay, now take a look at number 2. What is my little number base on my log? It's a little 2. How do I get rid of a log little 2? I use a big 2. And my little 2 and my big 2 are going to cross out. So I'm going to have 8 equals 2 to the x minus 6. And then I would look in my 2's chart and I'm trying to find the number 8. So let me put my chart back up here. There's the 2's chart. What is 8? 2 to the 3. So then I have 2 to the 3 equals 2 to the x minus 6. And then from there, what can we do? Cross out the 2's, and then this is where I'm going to flip-flop that equation. I'm going to let the x minus 6 comes first, and then I'm going to let the equals 3 come second. Okay, but if you don't want to do that step, I don't care. That's fine. Then from there, what do? Add the 6. So plus 6, and 3 plus 6 gives us 9. Very good. Okay, take a look at number 3 right next to that, please. What's my little number on my log? Then I'm going to use a big 2. So I'm going to have my 2 and my log 2 cross out, and I'm going to have 1 equals 2 to the x. From there, you may have forgotten this. Hopefully someone remembers though. What exponent can you put on any base to turn it into a 1?
0.
Wonderful, it is 0. So we're gonna make that 2 to the 0 equals 2 to the x. And then my 2's cross out. What's my final answer gonna be? Yeah. And remember, 0 is a number, so that counts as an answer. 0 can be your answer. Okay, let's get into a couple of the other special case scenarios that we looked at last time. So take a look at number 4, please. Okay, what's my little number that I need to cross out? So I'm going to use a big 7. So I have 7 and log 7 cross out. 1 over 49 equals 7 up to the x minus 3. Then I'm going to check my 7's chart, and I'm going to try to find 49 as a power on 7. So let me put my chart up here. Okay, 7's chart is right here. 49 is what? 7 squared, or 7 to the 2. Now, notice that that's not 49. That's 1 over 49. So I'm going to write it like this, where I have 1 over 7 squared equals 7 to the x minus 3. And then another thing for you to kind of remember, how do I pull that exponent, the 7 squared, off the bottom to the top? Kind of put a negative on it. You remember that? I know it's been a while. We had a 4-day weekend. So I'm going to circle this and put an arrow up. And then I'm going to say use negative. Okay, but the reason we're using the negative is because it was a fraction. If it's not a fraction, you would not apply a negative there. So now I have 7 to the minus 2 equals 7 to the x minus 3. And then from there, I can cross out my 7's and continue to solve. So these 7's here are both gone. I have negative 2 equals x minus 3. And then what would my last step be at that point? Add the 3 across. What is negative 2 plus 3? Very good. Let's see if I can do that. Plus 3. Okay, I guess we're not doing number 7 because I wrote all over it. Okay, good on that? Do we need to do one more of those, or do we kind of remember? We remember? Okay. If you need help with those on your practice, just ask me. Take a look at number 6 is another special case scenario. Number 6, what's my little number? Then I need to get rid of it with a big 5. So I'm going to have 5 on the log 5 crosses out. Root 5 equals 5 to the x. Then from there, we talked about this maybe last class, but what power is a square root the same as? Hint, it's a fraction. It is a half. What if it was a cubic root? 1/3. So I'm going to turn this into a half as the power. And then from there, now that I have 5 to the half equals 5 to the x, then I can cross out those common bases and I have my answer. So it'd be x equals a half. Any questions on that? Okay. All right, let's take a look at the bottom row here. So the rules stay the same. It doesn't matter if your base is a weird number. So for example, on number 8, what is your base? Tell me the whole number. It's not just 10, it's... What's the base?
10 square, or square root.
Square root 10, right? So how do I get rid of a little square root 10? Big square root 10. So you're going to put it on both sides. So it'd be root 10 here and root 10 here. And then what happens when you have a big root 10 on a log little root 10? Cancel out. So I have 10,000 equals root 10 to the x. Okay, so then from here, I want to turn my 10,000 into a base. So let me put my chart up here. Okay, the tens chart got kind of hole punched, but I want 10,000 here. What is that the same as? 10 to the power of 4. So I have 10 to the 4 equals. Now be careful on the other side. That square root is really an exponent in disguise. What exponent is it? So that's really 10 to the half. And then do you remember that if there was already an exponent up there, you would just kind of put it in parentheses like that. So if the x was already there, I'm going to keep it there in parentheses. Now that my 10s match, I can cross those out. And I have 4 equals half of x. Now, half of x is x divided by 2. How do we undo divide by 2? Multiply by 2. So I would times by 2 here, times by 2 here. And what is 2 times 4? So x would be 8. Very good. All good on that? Okay, take a look at number 9 right next to it, please. How do I get rid of a root 13 in my log? A big root 13. So I'm going to put it on both sides. So my root 13 on my log little root 13 are going to cross out. I have 1 equals. And then what can I go ahead, or actually let's keep it the same for now. So root 13 to the x. Okay, what can I use as an exponent if I want it to come out to be a 1? 0. And remember, I can pick whatever base I want. So if I want to match the base that's already here, what am I going to use? Can I pick root 13 so that they're exactly the same? Because root 13 is a number, right? So I'll do root 13 to the 0 equals root 13 to the x. And now that I have the matching root 13s on both sides, I can cross them out and x is going to equal 0. Okay, any questions on that? All right, turn the page when you're ready. Okay, we're going to work in all the other properties that we talked about last class. Everybody good? Can I pull this? All right, so take a look at the next one. You have a log with a what? What's your little number?
8.
It's an 8. How do I get rid of a log little 8? I'm going to use a big 8. So I'm going to do big 8 here, big 8 here. My 8 and my log little 8 cross out, and I have 5x plus 1 equals 8 to the 3. Now, this is different than the page that we were just looking at. Okay, here's why. In all of the other examples we worked, do you remember how your x was a little number in the exponent? Now, this is a regular x. Then I want this side to be a regular number so that I can solve it as usual. You're still going to use your chart, but you're going to find 8, 3, and bring it back to the other number. Good job, Jamori. Right here, 8, 3 is the same as what? 5, 12. So if your x is regular, make this side go back to a regular too. So I would have 5x plus 1 equals 512. And then how do I get rid of the plus 1? Minus 1. So 512 minus 1 would be 511. And then to get rid of that 5 on the x, I would divide by 5 on both sides. So my answer would be 511 over 5. Now, if that will divide evenly, for at least for your practice today, you could do it. So 511 divided by 5 is 1.02. So you could type it in either way. Okay, but if it came out to 1.0 to 0.2222222, don't do that. No rounding. Okay? All right, take a look at number 11. What are we going to do to both sides? Yeah, how do we cross out the base though? It's a log little 3, so I'm going to use a big 3. And when I big 3 on both sides, where are the logs going to cross out? Both sides.
Yeah.
Yes, so now it's just 4x minus 1. And then on this side, it's just a 2x plus 7. Okay, so if you end up with logs on both sides, that's actually nice because when you cross it out on the left, all of a sudden the other side crosses out too. Okay, how would I continue to solve that? I have x's on both sides. Subtract the 2x. Now you also could subtract the 4x, but I'm going to move them to the left. So 4x take away 2x gives me 2x minus 1. What will we do after that? Okay, add the 1. 7 plus 1 gives me 8. And then last step, get rid of that 2 by dividing. X equals what?
4.
Yes. Okay. So we've covered pretty much all of the scenarios where you have just one log. Now let's talk about what if you have more than one log. We learned properties for this last class, but I know it's been a 4-day weekend, so let's review what those were. We're going to start with the second property, so you're writing on the second line. If I have a log A added to a log B, we learned last class on Thursday that you can combine those into the same log if you do what operation with A and B? Do you remember? Oh, it is multiplication. Good job. So I can take those two separate logs and combine them into the same log using multiplication. Okay, rule number 3 is subtraction. Log A minus log B is going to use division. Very good. That's right. So I'll take log of A divide by B, and that will allow me to take those two separate logs and squish them together into the same log. There's one more rule. If you have a coefficient in the front of your log, so let's say we have n log to the A, where is that number in the front allowed to move? Do you remember? To the top. Very good, as an exponent. So my n will move from the front to be a log A to the n up top. And there are no more log rules. Those are the only 3. We're just going to reuse those today. So take a look at number 11. I have 2 logs and I can't get rid of them until they're combined. So if it's a log 6x plus a log 2, how can I combine those? Will I use multiplication or division? Okay, can you tell me if I multiply 6x times 2, what am I going to get? 12x, that's right. So now I have just one log of 12x equals 2. Okay, but how did I go to 12x? I took the 6x and the 2 and I multiplied to get them into the same log. Now, what was my little number that I forgot to write? And if it's a little 8, how do I cross it out? I use a big 8. So my little 8 and my big 8 cross out. My 12x stays equal to 8 squared. And then I'm going to look at that and say, is my x little that I need to keep the 8 squared little, or is it regular? That's a regular x. Then I want 8 squared to be a regular number. So what is 8 squared the same as? 64. And then if 12x equals 64, what's my last step? Divide by 12. So then in the calculator, I'm just going to divide that out and see if it comes out to a whole number. Okay, 64 divided by 12 is 5.33333. Should I put that in for my practice? No. What you can do, though, if you want to be a little lazy, is do your fraction, and it will still reduce it for you. So 64 over 12 is going to simplify to 16 over 3. So you can put 16 over 3. But remember, you would have to use the pretty fraction in the calculator for it to reduce it for you. There also is another way, but I would say that's the easier one. Okay, take a look at number 12. I have 2 logs. That's no good. I can't cancel out 2 logs, so I have to combine them. How are they together right now, with addition or subtraction? Okay, they're currently subtracted. Then how am I going to combine them to be in the same log? So I'm going to do 10x divided by 2. What is 10x divided by 2? 5x. So it'll be log 5x equals 3. But how do I know I'm dividing? Because it was subtraction this time. Okay, from there, how do I get rid of a log little 5? Big 5 on both sides. My log little 5 and my big 5 cross out. I have 5x equals 5 cubed. And then I would ask myself, is my x little or is it regular? That's a regular x, then I want 5 to the 3 to be a regular number. So let me put my chart up here. What's 5 to the 3? 125, then 5x equals 125. And what would my last step be? Divide that 5 off on both sides. So 125 divided by 5 gives me 25 as my final answer. Make sense? Okay, let's take a look at number 13. What property is going to come into play on number 13 that has not been in our other examples? The 2 log. Very good. We can't have the 2 there. So where can that 2 in this front spot move to be? An exponent up there. So now I'm going to have this. Log 4 plus log x squared. Okay, from here, now that I've moved the 2, how can I combine those separate logs into one single log? Multiply. And what is 4 times x squared? 4x squared. Now, I forgot to tell you this, but if your base is ever missing, so like for this one, do you see how it just says log and that's it? Anytime that happens, it's an understood 10. So there actually is a blank up here at the top of the page if you want to go in and fill it in. It says, if no base is listed, the base equals 10. And that's because we're in a base 10 number system. So put that right there. Okay, from there, how do I get rid of a log little 10? Big 10. So I'm going to big 10 here, big 10 on the 2. So 10 and log 10 cross out. I have 4x squared equals, what is 10 squared as a regular number? 100. And notice, why do I want it as a regular number? Because I got a regular x on the other side. What do I do next? Got to get rid of the 4, so we're going to divide by 4. What is 100 divided by 4? So x squared is 25. Very good. Now remember, x squared, I should be getting 2 separate answers. So it's 5 and what? Minus 5. Remember, whenever you take a square root, it's plus or minus that number. So it should be 5 and also negative 5. Okay, take a look at number 14. We got 3 examples left. We're almost done. I know this has been a little bit of a long problem set. So number 14, what can I move? The 2 log can't stay there. So bring it up as a power on the 3. So now I have log x minus log 3 squared. Now, if 3 squared is a number, let's just do it. What is 3 squared here? 9. Okay? And then I notice those logs are subtracted. Subtracted logs can be combined using what operation? Division. So I'm going to end up doing log x divided by 9 would just be x over 9. Now, I was a little lazy here and I forgot to put my little number. What was my little number in the log all along? It was a 4. So I'm going to put those 4s back here. Because how do I get rid of a log little 4? I have to use a big 4. So then my 4 and my log little 4 cross out. I have x over 9 equals. And then because my x is a regular x, I want 4 to the 4 to also be a regular number. So in my chart, what is 4 to the 4? 256. Very good. And then if x divided by 9 is 256, how do I get rid of a divide by 9? Multiply by 9. So this number is going to come out kind of big, but it's okay. So 256 times 9, answer comes out to be 2304. Questions on that? Okay, go ahead and turn the page. We're just going to do 2 more. Okay, almost there. Let's take a look at the first one. How many logs do you see total? 3. That's no good. You can't get rid of 3 logs. You can only get rid of 1 log at a time. So I need to combine those into 1 log before I can cancel it out. Are there any exponents I need to move first? That 2 is going to come up on the 4. So now I have log 5 plus log x plus log 4 squared. What is 4 squared? 16. Now, I'll come back and put in the 3's in a second, but for right now, I'm just going to worry about the logs. They're all added. And actually, I kind of want one of these to be minus for the example, so let's switch this one to a minus. Okay, so we're just pretending that was originally a minus 2 log. Okay, so from here, now, how am I going to combine those into the same log? What will I do with the 5 and the x? Multiply or divide? So 5 times x. But now that my 16 is subtracted, where will that end up? Where do the subtracted logs, how do they get combined? With multiplication or division? So that'd be a divide by 16 equals 3. What was my little number base? 3. And how do I get rid of a log little 3? Big 3. So I'm going to big 3 here, big 3 here. Big 3 on log little 3 is going to cross out. I have 5x over 16 equals. And then 3 to the 3 can be turned back into a regular number. So 3 to the 3 is what? 27. Okay, now our numbers are going to come out ugly since I changed the problem, but it's fine. 5x is divided by 16. How do I undo that? Multiply by 16. So 27 times 16 is 432. So I have 5x equals 432. And then from there, divide by 5. Very good. 432 divided by 5 is 86.4. Or if you prefer, you could do it as a fraction. Your practice will take it either way as long as it's simplified. Okay? All right, last one we're doing together is this last example down here, bottom right. What is your base in this final example? It's not a number, but that's okay. What is it? It's a little 2x. How do I get rid of a little 2x? Big 2x. Am I okay to come off of this first example? You good? Okay. All right, so I'm going to do a big 2x here and a big 2x here. 2x and 2x cross out. I have 3x squared plus 3x minus 2 equals 2x squared. Now, notice that it's not just the x that's squared, it's the entire 2x getting squared. Notice your x is not little, so I want this to be a regular term. So 2x squared means 2x times 2x again. What will we get for that? 4x what? Squared. So that's going to be a 4x squared. And now notice that if your equation has an x squared in it, that means it's quadratic. We're going to have to factor to solve that. Can I factor it as is and label my ABC? No, because I got terms on both sides. So I'm going to have to minus this 4x squared across. What is 3x squared minus 4x squared? Okay, plus 3x minus 2 equals 0. Remember, we always want quadratics equal to 0, whether you're doing quadratic formula, factoring, it doesn't matter. Can I factor with my a being a -1? Yes or no? No, we're going to have to GCF that -1 out to the front. So now my x squared is alone. What happens to my plus 3x? Minus 3x. And what happens to my minus 2? Now it's a plus 2. And now I can t-chart. So what numbers will multiply to positive 2? Yeah, pretty much just 1 times 2. But then if I need them to add to -3, I'm going to make them both minus. So I'd put minus, minus. Okay, because remember, for an add chart, you're either adding 2 positives or 2 negatives. Then from there, it's an x minus 1 and an x minus 2. If your parentheses are an x minus 1 and an x minus 2, then your answers will both be what? Positive. If they're negative in the parentheses, the final answers should be the reverse. So it'd be x equals 1 and 2. Will I have an additional answer of 0 because of the number in the front? No. What would have to be out there for you to get a third answer? An x on the outside gives you 0. I don't think so. You know, just trying to tie it all together, you know?
I was trying.
There's not one like that on your practice. Okay, so go ahead and pull up your Delta Math. I'll bring you some scratch paper. You guys all want all need paper over here? Take one and pass it. You guys all need paper over here?
I said it myself. Actually, no. I'm good.
You good?
Yeah, I said it myself.
Yes. I did get an email, y'all are doing the presentation.
Don't keep swimming.
That's no problem.
Just keep swimming.
Just keep an eye on the time.
These are the last like Chris had like 30
You okay?
pages.
I was tired today.
Never mind.
You do?
It's fine.
It's okay, bro. I didn't even know the schedule last year. So like the last My hips.
Bro, I have too much.
Your hips hurt?